Hello, this is Mrs. Sargent, and this is lesson 6.1, Parts of a Chemical Equation and Counting Atoms. So to start off with, we need to determine, has a chemical change taken place or not? And so we had 4 indicators for chemical change. We talked about these at the beginning of the year. Just to review, that is a formation of a new gas, a color change, a spontaneous change in energy, and that energy can be in the form of heat or light. Then a formation of a precipitate, a precipitate forms when you pour 2 liquids together and a solid falls out of solution. So we can represent chemical reactions. Chemists do this by statements called chemical equations used to represent those chemical reactions. And we have reactants and we have products. The reactants are the starting substances of the reaction. These are written to the left of the arrow, and the products are substances formed or produced by the reaction, and these are written to the right of the arrow. So I think about a production line or a factory. Let's say that we have a factory to produce computers. All of the elements and components, the internal part of it, those are going to be the reactants because we have to add all of those together. And then the final product is the computer that we use. So a chemical equation shows what happens in a chemical reaction. The reactants are on the left. So we have sodium and water as reactants, and our products are on the right. And we have hydrogen and we have sodium hydroxide as products. These letters in parentheses are indicating the states of matter. So the S in parentheses is indicating that sodium is solid. Water is a liquid, and I always write that as a cursive L. Water will always be liquid unless you were told otherwise. Like water vapor would be a gas. You have hydrogen gas. G is representing that it's a gas. And then we have AQ. And AQ means that it is aqueous. This means that it is dissolved into solution. So anytime you hear that you have a solution, it's going to be aqueous. The plus sign indicates that there is more than one chemical on each side of the equation. So anytime you hear the words and, you're going to put a plus sign. If you hear reacts with, you are also going to put a plus sign. The yield arrow is the arrow in your chemical equation. This separates the reactants and the products. And you are going to write this when you hear the words to yield or yields to produce or to form are going to be the main times that you are going to write the arrow. There will be a few more that we'll talk about later, but those are the ones that we need to focus on right now. And then these half arrows that are drawn horizontally, kind of like our orbital diagram half arrows, but these are horizontal, not vertical. This is indicating that we have a reversible reaction. And I don't think that this got printed in your packet, so go ahead and draw that in. The reversible reaction means that the reaction can go either way, and it separates the reactants and the products. We will talk more about that when we get to our chemical equilibrium. So in order to represent chemical reactions, we can do this with word equations or skeleton equations. Word equations use word statements that indicate the reactants and products to describe the reaction. So an example of this is solid sodium reacts with water to form hydrogen gas and aqueous solution of sodium hydroxide. A skeleton equation uses chemical formulas to identify the reactants and products in a chemical reaction. So these are the same reactions. Sodium is represented with Na, it's solids, we indicated that with the S. Water, H2O, it's liquid, because we weren't told otherwise. To form, we put in the yield arrow. Hydrogen gas, H2, it is a diatomic, so we had to put a 2 there, and then noted that it was a gas, and a solution of sodium hydroxide. So sodium hydroxide, hydroxide is a polyatomic, sodium is a 1 plus, hydroxide is a 1 minus, so those balance each other out. And then we noted that it was aqueous. I gave you the example, solid aluminum reacts with liquid bromine to produce solid aluminum bromide. Take a minute, pause the video, and try to write out the skeleton equation for that. Welcome back. Solid aluminum reacts with liquid bromine to produce solid aluminum bromide. So solid aluminum, Al, and we're going to indicate that it's solid, reacts with, so we're going to put the plus sign, liquid bromine. Bromine is Br, but bromine is part of our Brinkelhoff, so we have to give it a twin. And then we need to indicate that this is a liquid. To produce, we're going to put our yield arrow, and then solid aluminum bromide. Aluminum bromide. So we have to balance out our formula. Aluminum is a 3 plus, bromine is a 1 minus. We crisscross the numbers from the charges. This is our skeleton equation that I wrote here. If you had trouble going from the word equation to the skeleton equation, you need to review your naming and writing formulas. This is not going away, going from this to this. Come in, see me, get some help. The law of conservation of mass states that matter cannot be created or destroyed. The products must equal the reactants, and we do this by balancing the chemical equation. So whenever we balance a chemical equation, we're going to write down the elements that are on each side. It should be the same thing on both sides. And I always keep them even so that it's easy to see how many we have on each side. Then we're just simply counting the number of atoms. I'm going to do this quickly. There will be more on this in our coming lessons. I just want to show you that currently the numbers are not balanced on each side of the equation. So in order to balance it, that's what we need to do to show the law of conservation of mass. So if we have 3 and 2. So if I put a 2 over here, that's going to give us 2 sodium, 2 oxygen, and 2 hydrogen here plus 2 there, so that's 4. So then I would need to put a 2 here to get my 2 sodium, a 2 here, 2 times 2 for 4 hydrogen, and 2 times 1 for 2 oxygen. So now the numbers of atoms on each side of the chemical equation are equal to each other. This is showing a balanced chemical equation and the law of conservation of mass. So subscripts are the small numbers in your chemical formulas. This identifies the number of atoms in a compound. The coefficients identify the number of each compound. So subscripts are the small numbers, coefficients are the big numbers in front of your formulas. When we get into balancing, you cannot change your subscripts, but you will be changing the coefficients in order to balance it. That's these big numbers out front that I changed in order to balance out the chemical equation. So take a minute and circle the subscripts and box the coefficients in this reaction. Welcome back. You should have circled 3, 8, and 2 for the subscripts in your reactants, and then 2 and 2 for the subscripts in your products. 5 is the only coefficient we're given in our reactants, and 3 and 4 are the coefficients in our products. So, how many C3H8? Well, we don't have a number in front, so there is only one of those. So this is how many molecules of C3H8? We have 1. How many molecules of O2 do we have? Well, this 5 is telling us that we have 5 of those. And then our molecules of CO2, this 3 tells us that we have 3 of them. And then for H2O, we have 4. Okay. So now when we go to count our individual atoms on both the reactants and the product side, so remember our reactants are on the left, the subscripts tell us the number of atoms. So we have 3 carbon, 8 hydrogen, 2 oxygen, and 1 O2. But we have 5 of them, so 5 times 2 for a total of 10. Over here we have 3 times 1 carbon for 3. 3 times 2 for 6 oxygen plus 4 times 1 is 4, so 6 plus 4 gives us 10 oxygen there. And then 4 times 2 gives us 8 hydrogen. You need to be able to count the number of atoms correctly in order to be able to balance out your chemical equation. Then we have these 3 compounds. Take a moment and count up the number of atoms. Welcome back. You should have got 6 sodium, 3 sulfur, and 12 oxygen. You should have got 2 iron. You should have got 6 nitrogen, so 3 nitrogen, but then there's 2 of them, so 6. 3 times 2 is 6, times 2 is 12 oxygen, 2 aluminum, 3 sulfur, and 12 oxygen. You have practice on the next page. Make sure that you work through these. Again, if you cannot go from a word equation to a skeleton equation, you need to practice that. Go back, review your naming and writing formulas from Unit 4 in the blue packet. Come in and see me if you have any questions. Thanks. Have a great day.